This is part 2 of Unit 7, Lesson 9. I am on the website Algebra.org. It has a free graphing calculator that you can use. So we are going to continue with what we've been doing. Suppose a rock is dropped off a cliff that is 64 feet high. When will the rock hit the ground? It's going to give us this formula of h equals negative 16t squared plus 64. This is where h is equal to height, t is equal to time, VO is the initial velocity, and HO is the initial height. So 64 is the initial height. There is no VO, or initial velocity, since the rock is dropped and not thrown. So you can see I just entered the information right here, and it made this beautiful little graph for me. I can zoom out a little bit if you want me to, so I can move it around. You can see we have the x-axis, all of this nice information. I can zoom in, I can zoom out, I can scroll up and down. You can do all sorts of nice things, okay? So to answer the question of when the rock will hit the ground, plot points to make a graph of the situation. GeoGebra did that for me. So first thing we need to do is make a table of values. So I click on these three little dots and click Table of Values. And look at this. I already did this, so you enter your x values over here. So I did 0, 1, 2, 3, 4. And we see that it went 0, 64, 148, 2, 0, 3, negative 80, 4, 192. So what this tells me is that it's going to hit the ground at about 2 seconds. Okay, you can come down here. Ooh, sorry, I did the wrong thing. Let's zoom in a little bit. Let's get to our x-axis. You can see here it hits the ground. Okay, so here at the y-intercept, at 0x, 64 h of x, that's where it's dropped. That's the y-intercept. It starts at 64. It was at meters, I believe it was meters, and it gets dropped and it's going to hit the ground and stop moving at 2 seconds, okay? So that means that the t has to be greater than or equal to 0 and less than or equal to 2, and h has to be greater than or equal to 0 and less than or equal to 64. So when we're graphing, we need to make sure that we have the x-intercept, the y-intercept, the minimum and maximum values on the table. So I had 0, 1, 2, 3, 4 because I had y-intercept, I have x-intercept, I have maximum value, I have minimum value. These are irrelevant. We can stop here because the ball is not going to go below the ground because it's a ball, or whatever it is that we dropped. It's not going to drop below the ground, okay? So we know that because the original formula, let me see if I can get it back, because this 16 is negative, we know that the graph of the parabola will be a downward U shape. You can see it's like an upside down U right here. We'll come back up here and you can see that it has a U right there, okay? That's because 16 is negative. So the rock will hit the ground in 2 seconds when t equals 0 and h equals 8, which we can see on our table. It doesn't want to let me go back to the table, and I don't know what all this is. There's intersects. Okay. Wow, I didn't mean to do that. Can we go to the table here? Okay, we can. We plot, so because we don't need to deal with negatives, because we can't drop from a negative height or a negative time, we're really only dealing with this quadrant right here. So the only parts of the line we're dealing with, let me zoom out, is from here to here, from point D to point B. We don't need to worry about anything else in any of these other quadrants. We're only dealing with quadrant 1, so we're only seeing a small portion of the parabola, okay? I'm sure there is a way on this to mess with these ranges, these intervals, so that you can make the arc more visible. I'm going to pause the video and see if I can figure that out. think I might have figured it out. Let's see if I can do it again. I clicked to zoom to fit, and it messed with the ranges here. So now it's got like 0.2, 0.4, 0.6, 0.8 for the seconds, and then it's going by 50, 100, well, I mean it's 10, 20, 30, 40, 50, it's going by tens. But this allows you to see the range a lot better. I'm sure there's another way to do it that's much more detailed and puts you in control, but why make it harder than it has to be? This allows you to see, and I just zoomed in, it allows you to see just this quadrant, and in a way that allows you to look at a much more detailed rather than having it all be right here and like super complicated. So let's go ahead and do another one. We're going to delete this one so that we don't get confused by what's going on here. Our points are all screwed up, but I think I know how to fix that, so we're going to figure it out. So it wants us to identify the maximum, for this graph. So we have y equals negative x, and I need my little thingy back so I can get a squared. Negative x squared plus 6x minus 4. Okay, now let's come down here and I'm going to go zoom to fit. How's that? Oh, yeah, that didn't work so well. Zoom to fit. Let's go clear all traces. Let's go snap to grid. Okay, maybe what we need to do is go delete. I'm learning. We're learning together. Clear all. Let's try that. Let's try that. Oh, cancel. No, I don't want to save. I guess it helps if you read, huh? Clear all, discard. Okay, now we're back to more normal. Let's try entering our information again. We have y equals negative x squared plus 6x minus 4. Okay, there's our graph. Okay, so this is honestly pretty reasonable. I wouldn't worry about it too much, but let's see what happens when I go zoom to fit. Woo, okay. Oh, dang. Control Z is my friend because it allows me to, oh, it's still being strange. I'm not sure. Okay, well, I don't think I wanted to do it on that one, so we'll just leave it because this looks pretty. So what it wants to know is the maximum of the graph. So we have the graph is pretty. The maximum is right here, which is extremum. I like that, extremum, and it tells us straight up it's 3, 5. It's 3 on the x-axis, 5 on the y-axis. Now I learned my lesson, so I'm going to come up here. I'm going to go clear all, and we don't want to save it. I don't need to save a million graphs in my computer. No. There we go. Make your day a little bit better because I totally screwed this up. Let's go try this again. Okay, this problem says Anna owns a candle making business. Anna's profit is modeled by the equation P equals negative 20c squared plus 1200c minus 10,000. When I enter it with the P and C, for some reason it freaks GeoGebra out and it can't handle it. So we're going to use x and y. So we have y equals negative 20x squared plus 1200x minus 10,000. You can handle it, but not if you do P and C. It just doesn't work that way. Okay. C, in this case X, represents the price of a candle. P, in this case Y, represents profit. Find the prices where Anna's profit is 0, the break-even prices. So the first thing we need to do is create a table. So we'll come here to our table. We're going to start with a 0, and then we know that because it gives us the information, it says that negative 10,000 in the formula is what Anna loses when she doesn't have any, when she doesn't sell any candles. So she pays $10,000 at the start. If she sells 0 candles, she's $10,000 in debt. So we're going to go in increments of 10 candles and create this table. So 10, 20, 30, 40, 50, 60. Now, a second ago, this was working, and I don't know why it's not working now, because I guess it's my life. But let's go ahead and zoom to fit. Okay, it's got our nice little curve here. So at 10 candles, it says we're at 0 still, which is correct according to their table. Okay, so at $10, at 10 candles, she breaks even. Apparently, she's selling these candles for $1,000 a piece. I don't know what's in these candles. This is our x-intercept. Okay, at 20 candles, she is sitting at 6,000. You can see that. You can just follow that across. So $6,000. At 30 candles, she's $8,000. And that's the extremum. I love extremum. That makes me happy. So that is the maximum amount. Okay, 8,000. Come here. 8,000. Okay, at 40, she's going back down again, so she's right here. And it doesn't like that point, but that's at 6,000 again. Okay, at 50, she's back at 0. Hello. And at 60, she's down in the negatives at negative 10,000. Okay. So we have, not negative 1,000, negative 10,000. So now we have our table. Okay, we have our table with all of our points. And then it graphs the parabola, and guess what? All of our points line up on the parabola that it gave us, so we know we did it right. Okay. So remember that this problem has two x-intercepts. It has one here at 10 candles and one here at 50 candles. Those are her break-even numbers, where she's not in the green, but she's not in the red. She hasn't made any money, but she hasn't lost any money. In between those two numbers, she's making a profit. Alright? Make sure before you move on to clear all, and don't save it. Don't bog down your computer with this garbage. Now it wants to know, what are the x-intercepts for the graph of y equals 2x squared minus 5x minus 12. And look at that, we have our x-intercepts right here. We can just click on it. Our first one is negative 1.5 and 0, and our second one is 4 and 0. I love technology. Miss Cato is designing a rectangular garden. She has 240 feet of fencing. Miss Cato is going to use the back of her house as one side of the garden. The fencing will be used on the other 3 sides. What should the dimensions of the garden be to maximize the area of the space? So she already has fencing for the back wall, but she needs 2 sides and 1 front in order to do this. So that means that she has a width, and a length to deal with. So she has 240 feet of fencing minus 2 times width, because she has those 2 side panels. Okay, that will give her the length that she needs. So 240 minus 2 width times width, all of that times width will be the area. In the end, your area formula is going to be negative 2w squared plus 240w. Okay, so first we're going to make a table for that formula. So let's come over here, and we're not going to use anything except y and x because we learned our lesson. So we're going to say y instead of area is equal to negative 2x instead of width squared plus 240x instead of w. Okay, we're going to go ahead and come here and go, oh no, did you do this for us? We're going to hit enter because sometimes enter helps. And we're going to go zoom to fit. Okay, I'm going to zoom out a little bit because I can't really see what's going on. Okay, this is looking a little bit better. This wasn't a very good zoom to fit. They didn't really scale it well for me, but that's okay. We'll just pretend that they did. Holy smokes. Okay, whatever. This is what it is. We'll just deal with it, alright? So we're going to make a table of values. Let's see if it did it. Table of values. Start value. We're going to say the start value. I've never seen this before. I don't know why it did this. We're going to say the start value of x is 0 and the end value is going to be 120 because that's how much fencing we have. And we're going to do steps of 30 because that's what they used. Sure. Okay, so there's our table at, oh, no, they went 0, 20, 50, 60, 70. They did something weird. But whatever, here's our table. Let me see if I can change that. Edit. Okay, let's go by 20s and see if that gives us better options. Okay, so we have 0, 0, 24,000, and then see it does like 50 and then 60. I don't know why it's doing these randomness. But 60 is 7,200, and this is our maximum, or as they call it, extremum. So we have an x-intercept here and an x-intercept here, which is the information that we want. So the maximum area Miss Cato's garden maybe is 7,200 square feet. That's a huge garden. Wow, that's like way, way big. This will happen when the width is 60 feet and the length is 120 feet. See, the width is 60 feet, the length is 120 feet. Okay, so and then it tells you to graph it, and it's going to look something like this, except it should have much better scale than this, because we wanted a scale that was every 500 feet, and instead it's doing like, I don't know, 10, 20, 30, 40, 50, nope, I don't even know, 25, 50, 75, 100, I don't even know what these intervals are, but they're weird. Let me see if I can zoom to fit again and if it'll fix it. It's a little bit better. That's doing every 1,000. It wants us to do every 500. Oh, what is it? Is it the axis I'm clicking on that's messing it up? Zoom to fit? I don't know. Anyway, that's a little bit more reasonable. I'm learning GeoGebra with you as we go. Make sure that every time you're coming up here and clearing all and discarding. A ball is kicked from the ground with an initial upward velocity of 80 feet per second. This situation is modeled by h, which we're going to change to y, is equal to negative 16t, which we're going to change to x, squared, plus 80t, which we're going to change to x, where t is the time in seconds and h is the height of the ball. Find the h coordinates for the following ordered pairs. Use symmetry to help. So let's see if we can zoom out on this. Oh my. Let's, okay, that didn't work. Let's zoom to fit. Nope, it didn't do anything. Let's zoom to fit. It didn't do anything. Okay, let's just zoom out some. Goodness. Okay, let's see. Will it give us a table? We are dealing with a ball that is kicked from the ground. So the start value for x, we're dealing with time and height. So start value of x is going to be 0. End value of x is going to be 0. And we're dealing with like 80, so we'll go steps of 10. Oh no, that's actually really small. On the x, we'll go with 1. See, I'm learning with you. Oh, I think this goes to, what is this end value? Can it tell me? We'll go 10 because I don't know what that is. 10 will cover it, sure. Okay, so let's zoom in here. What is this one? Because this is time. Anyway, it wants to know what it is at 2. So at 2, it's 96. At 2.5, now this is what I love about this. I can come down here and go 2.5 and hit enter, and look, it tells me. At 2.5, it's 100. At 0, it's 0. And at 1, it's 64. This is really handy. This is really nice. Let's go ahead and clear all and discard. Jake has a side business making pottery. His monthly profit is modeled by the equation P, which is going to be y, equals negative 0.5x, but they're using n, but we're using x, squared plus 55x, x, that was a little interesting, minus 500. I fat fingered the keyboard. Let's go ahead and zoom to fit so we can kind of see what we're doing. Let's try zooming to fit again. Nope, that didn't help. But, you know, we'll do what we can do. It says N, which is X, represents the number of pieces of pottery sold, and P represents the monthly profit, and our formula P is Y. How many pieces of pottery does Jake's business need to sell each month to maximize his profit? Find 5 points to plot to show the graph that will answer this question. So let's see if this will give us a table. It will. So for the X values, let's come down here so I can see what we're dealing with. Because I mean, why work harder when you can work smarter? It's going to give us the X values. We're going 0 to 100. So let's go table. Doop. Start value for X is going to be 0, and value for the X is going to be 100. And because we're going 0 to 100, I mean, that's kind of a lot. We'll do steps of 5. Okay. Let's see what they got. So at 0, we're negative 500. At 10, we're at 0. At 20, we're at 400. At 30, we're at 700. At 40, we're at 900. At 50, we're at 1,000. At 55, we're at 1,012.50. At 60, we're at 1,000. 7,900. 8,700. 9,400. 100, 0. Okay, so Jake's business needs to sell 55 pieces of pottery each month to maximize profit, because that is our highest. Gosh, I hope his pieces of pottery are really easy to make and really small, because I mean, making 1,000 pieces of pottery and selling it every month, 1,012 and a half, so 1,013 pieces of pottery every month is kind of crazy. Okay, at this point we're going to go check out our practice and our quick checks, so let's get rid of everything. Number 3 on the practice says graph the function f of x is equal to 2x squared minus 2x. Okay, we just graphed it. Look at us, so good. What is the value of f of x when x is equal to negative 1? So we just come up here. Let's see if it'll make a table for us, because that makes it start value for x, we're going to say negative 2, and end value of x can be 2, sure. Just because it will for sure show our negative 1. So this point at negative 1, our value for y, f of x is 4. It was that easy. Okay. And then it says, first we're going to clear all. This is number 4 on your practice. It says graph the function, f of x is equal to 2x squared minus 2x, and true or false, the x-intercepts of this graph are. So let's make a table. Sure, that's great. The x-intercepts are 0, 0, and 1, 0. That is true. That was easy enough. Okay. And then question 5, I believe we can do too. So let's clear all. No, I don't want to save this. I do that every time, just out of habit. Okay, and the last one says, if the profit is represented as P, which is going to be Y, is equal to negative 5x squared plus 1,000 x, not s, x plus 5,000, okay, where P represents the profit and X represents the amount spent on marketing, what is the dollar amount that should be spent on marketing to achieve the maximum profit? So let's see if it will zoom to fit for us. And can we make a table? Sure, whatever. And look at that. There's our extremum right there. which is our answer. The dollar amount that should be spent on marketing to achieve the maximum profit is $55,000. I wish I was dealing with that kind of money in my life, but I could just throw around. Alright, and then on your quick check, it looks like you can do number 3, number 4, and then I think we have to keep working in order to answer number 5 on the quick check. So let's continue. You can pause the video if you want to and go do those quick check things. And we will go back and continue with our, hopefully, yeah, it is our last section. Alright. Actually, at this point, you can go ahead and do number 5 too, because it wants to know what the vertex is. And the vertex is just the maximum height of your parabola and how long it takes to reach it. So it's the XY coordinates for your maximum. It's looking like the rest of this lesson is just going to be finding the vertex, so you're welcome to watch it if you want to. But if you feel confident, then go ahead and end this video because you've completed your practice and your quick check. One thing you should know is that the vertex can also be the lowest point of the parabola. So it's wherever that peak of the arch is. It could be lowest or highest. Here's an example of finding the vertex. We need to find the vertex of y equals x squared minus 5x plus 4. Okay, and it's going to be right here. So it's going to be a minimum, not a maximum, but there's your extremum, 2.5, and negative 2.25. And it's a minimum, not a maximum. Let's clear all and move on to the next one. Suppose a student athlete throws a shot put at a track meet with an initial upward velocity of 48 feet per second from a height of 6 feet. This situation is modeled by x, which will change to y, equals negative 16x squared. I'm changing the random letters they're using. No, go away. Not x squared. Plus 48, they're using t, we're using x, plus 6, where t is the time in seconds and h is the height of the shot put in feet. Let's go over the key points on the graph. Here is, let's see if I can make a table because it's just going to be neater. Here's one of the x-intercepts. We would have to extend this. Let's see if I can, nope, that's not the one I wanted. We're going to extend this, the end value of x to 4, so that we can get our other intercept. It didn't do it. But the x-intercept is right there, so I don't understand why. Whatever. Here's your x-intercepts, okay? And the y-intercept, is right here at 6. And the axis of symmetry, which is the line that divides it exactly equally in half, is going to be, we need to get this up to 42. So what do we need to get it to 42? Look at me scrolling. I went right past the x-axis because I'm so good. Let's try 0.5, 0.8, 0.9, 0.97. Can I put in the y? Will it let me? No. I was hoping it would let me put in the y and figure out that way. Because the y-intercept, not the y-intercept, my maximum is going to be right there, and I can't, oh, there, will it let me now? There's my extremum. It's 1.5 and 42, so 1.5, enter, and 42 is going to be our extremum. That 1.5 is where the axis of symmetry is going to pass through, and that's the line that comes straight through it and makes a mirror image on either side for the parabola. So the vertex is a maximum, and it's this 1.542. That is all of the information on here. We don't need to worry about the negative values on the graph because they're irrelevant. You can't have negative time or a negative height for throwing a shot put. That just doesn't make sense. Let's clear all. Guess who screwed it up completely again? Okay, I'm going to have to go try again. Okay, I just found an easier way to do all of this. So here's our formula for the problem. It says John owns a jewelry making business. His profit for selling necklaces is modeled by the equation P, which we substituted for f of y, is equal to negative 10x squared, we substituted n for x, plus 600n, we substituted x, minus 5,000, where x represents the price of a necklace and f of y represents profit. So if you come right here, I'm so smart, there's a thing that pops up that's like key features or something like that. Well, I'll show you again. The x-intercepts are 10, 0, and 50, 0. Okay. Let's see. The axis of symmetry is at 30. X equals 30. That's where you draw the line straight through and then it's a mirror image on each side. The vertex, which is also the extremum, it's a maximum because it's up here, and it's 34,000. Okay, let's clear all this. And, no, I do that every time, I swear. Okay, if I wasn't doing 87 things at once, I wouldn't be this stupid. I'd be close, but not this stupid. What are the x-intercepts of y equals negative 2x squared plus 13x minus 15. Okay, and I'll show you. It says right here, special points. Boom. So the intercepts are are 1.50 and 50. It's just that easy. It will just tell you it that quickly. Now we're going to look at some parabolas that have a minimum instead of a maximum. Suppose a swimmer dives into a pool from the edge. This situation is modeled by d, which we're going to say is y, is equal to 3t, or x, squared minus 15t, or x, where t is the time in seconds and d is the depth of the diver in meters. And it wants us to look at the key features, which are the special points. So the intersects are 50 and 00. The extremum is, if we come down here and look, a minimum, which is 2.5, and this negative 18.75. The axis of symmetry is x equals 2.5. The y-intercept, which is right here, they call it the intersect, is 0, 0. The City Council has approved construction of a rectangular playground in a park. The builders have 600 feet of fencing and want to maximize the area of the playground. This situation is modeled by A, we're changing it to y, is equal to negative w, which we're going to say is x, squared, plus, 300w, which is x, where w represents the width of the playground and a represents the area of the playground. Explain the meaning of the x-intercepts and the vertex of this parabola for this context. Okay, let's zoom out. Actually, I think I need to go zoom to fit. There we go. Okay. Let's look at our special points. So, the x-intercepts are 0, 0 and 300, 0, and that means the width of the playground needs to be between 0 and 300 feet. Okay. The vertex is 150 and 22,500. That means that a width of 150 feet will give a maximum area of 22,500 square feet. Okay. A ball is kicked from the ground at an initial upward velocity of 34.3 meters per second. This situation is modeled by the equation h equals negative 4.9 t squared plus 34.3t, where t is time in seconds and h is the height of the ball in meters. Explain the meaning of the vertex and the larger x-intercept of the parabola for this context. So let's look at the special points. The vertex is right here, the extremum, and it's 3.5 and 60.025 meters. And then we have the bigger x-intercept is 7 and 0, and that means that the ball returns to the ground 7 seconds after being kicked. And guess what, my friends? This lesson is over. Congratulations.